Hello guys, welcome to today's video. Today we are going to discuss the second part of this chapter, acid, base and salts, that is the bases. Salts is also a very small portion, so I will try to keep the salts also in this video. So let us begin the video. Today our topic is bases. In the last video we have discussed about what is an acid, classification of acids, then we have learnt about the properties of acids, chemical properties and both physical properties. So the same thing we are going to apply to the base also. First let us know that what exactly is a base. What do you understand by a base? Base is something that will react with an acid to give salt and water. You know that, and that is also a definition. So how will you frame the definition? So in the definition of the base there must be two very important things. What are the things that are very important? When you are writing the base definition, base is either a metallic oxide, okay, I am just writing the important things, okay. So base can be a metallic oxide or it can be a metallic hydroxide or it can be an ammonia solution. You can understand that, okay. It can be even an ammonia solution. How? Ammonium solution, like you can check NH4OH or NH4CO3 or NH4 2-SO4, these are all bases, okay. NH4CO3 whole 2, okay. This is metallic oxide hydroxide. Next is on reaction with acid. On reaction with acid gives salt plus water. If you write this much, it is wrong. What you have to add? What is the word? Only. This word only is very important. If you miss out this word only, then it will cause you problem. Why? I will tell you a little bit later. So this base can be a metallic oxide. That means it has to contain O2 minus I. Metallic hydroxide has to contain OH minus I. You can understand. Hydroxide is OH minus I. And this is an NH3 solution, so it will have NH4 plus I, right? So this is going to have what ion? Ammonium ion. Okay. On reaction with acid gives salt plus water only. If anything other than that comes out, then it is not a base. Example. Okay, check. This two part is clear. Now reaction. A reaction I am giving PbO2. Okay. It is lead 4 oxide. Adding it with HCl solution. What will it produce? Very interesting. PbCl2. Fine, accepted. What else? Water. Fine, accepted. Another product is there. Cl2. Now my question is that is this a base? PbO2 is a base? No. Why? What is the reaction? What is the definition saying? Definition says salt and water only. Is this chlorine a part of the syntax given? No. This chlorine is what? Extra. So extra substance is being produced. So we will not consider lead 4 oxide as a base. Reason? Only salt and water is not formed. Chlorine is also formed, which is an undesirable component if we abide by the definition. Okay, if we abide by the definition, then this is an undesirable content, which is not one. So this is not acting as a base. So that is why this word only is very important. If you miss out the word only, then you know what is going to happen. Okay, then many other things will come into the category of base, which is not actually a base. Okay, next comes alkali. Now everyone knows what is an alkali. What is an alkali? Alkali is a water soluble base. Alkali is a water soluble base. Alkali. Water soluble base. Water soluble base. Okay. A base that is soluble in water is said to be an alkali. Examples. Very easy example. Write the example of NaOH. Then write the example of KOH. These are all water soluble bases. Okay. What else? We have a CaOH whole 2. then we have is NH4OH. Okay, so these are all water soluble bases. So these are all alkalis. Okay. Now why we are written it separately to differentiate? This is called strong alkalis. These are strong alkalis. Okay. These are weak alkalis. Now why are they said to be strong, weak? That will come in a little bit later. That is when we do the classification of bases. Okay. Now the main thing that I need to say to you here is that alkali is a water soluble base. So all alkali are base, right? All alkali is a base. But if you write all bases are alkalis, it is wrong. So all alkalis are bases, but all bases are not alkali. Example. What example can you do? CuOH whole twice. Then FeOH whole 3. These are all insoluble bases. Remember, analytical chemistry is there. When you come to analytical chemistry, so this reaction is again there in analytical chemistry also. The reaction is there here also in analytical chemistry also. So these are all insoluble bases. They are all precipitate. This is pale blue precipitate. This is reddish brown precipitate. So these are precipitate. So they are insoluble. So they are bases, but they are insoluble. So these are not alkalis, but these are bases. Okay. This is alkali, basic alkalis. Okay. Next, let us move on to the classification of bases. Just like we classified acid based on its sources and on its basicity, we will be classifying bases based on their strength and acidity, as I already said. Acid is basicity, base is acidity. So the first step of division is strength. Now what do I understand by the word strength? Strength of an acid. What is meant by the strength of an acid? The strength of an, base. Strength of an acid also I told in the last video that it is that how many H3O positive ion will produce. That is the degree of dissociation, right? Strength, based on strength, we are classified into strong and weak. That means this will be complete dissociation. Okay. And this particular thing will be partial dissociation. This term you will get again in when you learn the chapter electrolysis. Partial and complete. So first is strong, complete dissociation. Dissociation is complete. Example. Suppose I take NaOH. Okay, this is fused. Let us take fused. Okay, fused or aqueous or molten, because you cannot do it in solid state. Electrolysis says that. So NaOH will dissociate Na plus OH minus. Okay, let us take water is there. Clear? Fused state I am taking. Okay, but I just wrote water to make you understand. Okay, fused state, we need not write that, but still I wrote just to show you. Okay, so it will form Na plus and OH minus. So OH minus and Na plus, these are original constituents of this, so they are completely dissociated. So this is the strong alkali. It is an alkali, so I use the term alkali. Okay. Now weak, as I already told before also, that weak alkali. So we can write them as weak base also. Because alkali base is same thing. Okay. Alkali is a base, right? So we can substitute the word alkali by a base also, but not the base by alkali. Okay. So CaOH whole 2. It will form Ca2 positive plus OH negative. So this is a weak dissociation. Clear? Degree of dissociation is weak. So this is a weak base, partial dissociation. More visibly understood when you write ammonia solutions. Okay. Suppose NH4OH. So it will dissociate into NH4 positive plus OH negative. This is still a polyatomic radical. Clear? So this is again a weak base. Clear? This is strong, weak. Understood? This will conduct more electricity, this will conduct less electricity. This part again is there in electrolysis. Okay. Now let us move on to the second classification basis, that is acidity. Acids, basicity, basics, acidity. So number 2 division is acidity. Now this is not the acidity which you have, this is the acidity that bases have. Acidity means the number of OH minus produced per molecule of the base in aqueous solution. OH minus, how many produced per molecule in aqueous solution, it is called base, acidity. Okay, per molecule. And compulsory thing is that it has to be a aqueous solution, right? So OH minus ion per molecule in aqueous solution is said to be acidity of a base. So based on acidity, we have classified the bases into three things, that is monoacidic, diacidic, triacidic. Just like we did in case of acids, similarly we will do in case of base. Clear? First one is right. Number one, monoacidic base. By the term mono, you can understand that it is only one OH minus ion. So monoacidic base. Clear? That means one OH minus. Example, NaOH. Clear? Number two is diacidic base. Number two, it's diacidic base. Diacidic base indicates that there will be two OH minus. An example, CaOH whole 2. Clear? Number three, it's triacidic base. Number three, it's triacidic base, which indicates that there will be 3 OH minus. Example, aluminium hydroxide. Okay, and copper hydroxide. Clear? Copper 2 hydroxide. Clear? Okay, is it clear? Copper 2 hydroxide, put it under diacidic base. Leave it. Copper 2 hydroxide, put it under diacidic base. Here you put aluminum hydroxide and ferric hydroxide. Okay, not copper, ferric hydroxide. So triacidic base will be ferric hydroxide and aluminum hydroxide. Diacidic base is copper hydroxide, 2 hydroxide, copper 2 hydroxide and calcium hydroxide. Okay. Okay. This is the three classification of acidity of a base. Understood? Okay. Next part comes is how to prepare this base. Just like we had done the preparation of acids, in a similar way we will be doing the preparation of a base. Now how to prepare this base? How did we prepare acids? By oxidation, by action of water or non-metallic oxides, like this. Similarly, in case of bases also we can prepare in such a similar way. Now how? First way is reaction of an active metal with oxygen. Okay, reaction of an active metal with oxygen. Like if we write Na plus O2, it will end up forming sodium oxide obviously. It will end up forming sodium oxide. The first thing you can do, balance reaction. How will you balance? Two reaction, 2 Na will be here. So oxygen becomes 2, right? So if your oxygen is 2, oxygen is 1. So if you place another 2 here, this 2 will become negative 4. So now let us not take 4, set aside 4. Done. Okay. So 4 Na plus O2 forms 2 Na 2O. This was the first format. That is reactive metal acting with oxygen to form respective metal oxides. Next is action of water on respective reactive metals. Suppose I write Na plus H2O. What will it give? Same product? No. What will it give? NaOH. Clear? Reaction of active metal with water will give you NaOH as a product. Something else is also there. What is that? Hydrogen gas. Clear? Hydrogen gas. So see, NaOH2 which releases hydrogen gas and H is present over there. Is it clear? How to balance this reaction? How to balance this reaction? Achha, check. 2 hydrogen, 2 hydrogen, 4 hydrogen can be made. So here we can place 2, 4, yes. So we can place a 2 over here. So this means 2, this means 2, right? Okay. So 2Na plus 2H2, so it's 2NOH plus H2. Okay. Next is action of water on oxides. Now this product can also be obtained by reacting this with water. How? Na2O plus H2O will also form NaOH, but in this case there will be no hydrogen gas evolved, only NaOH will be the product. Okay, there will be no hydrogen gas evolved, only NaOH will be the product. Clear? Okay. Next is number 4, that is the double displacement reaction. These reactions are also there in analytical chemistry again. So if I react, let us react ZnSO4 plus NaOH. Okay, little, let us take little. Okay, so if we react it with little, let us not take NH4OH, no, that will also react with NH4OH also. Okay, NH4OH. Okay, so what it will form? ZnSO4 plus NH4OH. This reaction is there in analytical chemistry also. This reaction is there in analytical chemistry also. If you have read analytical chemistry before, then you might have got this reaction there also. Right? Right or wrong? You might have got this reaction there also. So what will it form? ZnOH whole twice. Right? What else? Plus NH4 whole twice SO4. Right? This will be a precipitate. This will be a precipitate. If you add excess, it will dissolve in it. If you add excess, it will dissolve in it. If you would have taken NaOH also, then also the same precipitate will have formed. Right? In case of little. So if I write now NaOH in little, then the precipitate also will remain same. Okay, what will be the precipitate? Na2SO4 plus ZnOH whole 2. Right? But if I add it in excess, this will dissolve to form Na2ZnO. But I am not there right now, so no need to worry about that. Okay. So the product obtained is a base. So this is how you get the answer. Okay. Next is action of oxides. Action of oxides. Action of oxides on sulfides. Action of oxides on sulfides. Suppose ZnS plus O2. Right? In the acid case, we have done this reaction only, but instead of O2, we have done HCl. So HCl gas was released. Right? Okay. But here it is O2. So what will be released? ZnS plus oxygen. ZnS plus oxygen. Zn will go with O. One is O is still left. What will form? Sulfur dioxide. So this will give you sulfur dioxide plus zinc oxide. This will give you sulfur dioxide plus zinc oxide. Okay. Balance the reaction. Okay. Balance the reaction. Okay. Next is if you decompose the salts. Decompose the salts like CaCO3. Decomposed. So what will it form? CO plus CO2. This is also a base. Quick line. Right? Okay. There is an exception. If you write Na2CO3 in this case, it will not dissociate. Okay, they are very high resistant to heat. So Na2CO3, K2CO3 will not dissociate. It is a very important reaction. Okay. Next is in this place, if you place a metal nitrate, that will also dissociate. Decompose, I mean. Okay. PB3NO3 whole 2. You already know the reaction. PBO will form. Then what will form? NO2 will form and O2 will form. Right? This is the reaction. This is color, you know. This color is reddish brown. Fumes, and this is observation. So this is the reaction that is being possible. Okay. Again, same exceptions comes here. That is Na2CO3, NaNO3 and KNO3. They will not decompose to form this particular reaction. Clear? Okay. Now let us learn about the properties of bases. Now let us learn about the physical properties of base. Then we will come to the chemical properties. First, let us learn about the physical properties. In the physical property of the acid, we have learned the indicator change, the color change. Same thing we are going to learn over here. One common thing we have learned is that acids are very good electrolytes, bases are also very good electrolytes. Acids, they had a sour taste. Bases, they will have a bitter taste. Okay, acids had a sour taste, now they will have a bitter taste. Base, clear? They also change the color of indicator. They also change the color of indicator, but color change of indicator is different. Okay, first change in color of indicator. Litmus, blue, right? It was red for acids, that is blue. Next comes methyl orange. Next comes methyl orange. Color will change to pink in case of acid. So in this case, it will change to yellow. What was the original color given here? Orange. Clear? Next comes phenol pH phthalate. Next comes phenol pH phthalate. What was the color in acidic medium? Original color. It is colorless. What will it change to here? Pink. Colorless to pink. This is the basic color change. Another one was the red cabbage extract. In the last part only I told you about that. Red cabbage extract, that is turning green in basic solution. It was remaining red in acidic. Okay. But here it will turn green. So red cabbage extract can also be asked. Red cabbage extract, it will turn green. Okay. it will turn green in case of bases. So these are the 4 possible litmus indicators that you need to read. Okay, you need to memorize actually. Okay. Next, let us move on to the other property. So as I already told you, they are very strong electrolytes. Done. Next, they are soapy substances. Okay, they are soapy substances. Okay. Next, they show mild corrosive action. Like acid showed strong corrosive action, bases will show mild corrosive action. Okay. These are the physical properties that you need to remember about the bases. Physical properties about the bases, this much. Now comes the chemical properties of the bases. What are the chemical properties of the bases that you need to remember? Chemical property, that means reactions will come into play. First one, base absorbs carbon dioxide. Certain base, you already know, you have studied in biology, that is KOH absorbs CO2. So what will happen to KOH? KOH added to CO2. What will happen? K2CO3. Right? K2CO3 will be formed along with something else. What? Primary constituent, water. Clear? So this is CO2. So they react with CO2 to form respective carbonate. So they absorb carbon dioxide. Second reaction is neutralization reaction. I have got nothing to say about neutralization reaction. It's very easy. I am just showing one. NaOH plus HCl forms NaCl plus H2O. Right? This is an example of a neutralization reaction. Clear? Okay. Next is precipitation reaction. Double displacement precipitation reaction. That also I have shown in the last reaction only, that ZnSO4 plus NaOH will form Na2SO4 plus ZnOH holder is a precipitate. So that is again a base coming over there. Okay. So these are bases being formed. That reaction I am not writing anymore. Okay. Next one is this alkalis when they are warmed with the ammonium salt, ammonia gas is given out. This reaction again is there in analytical chemistry also. What I mean, if alkalis are warmed with any ammonia solution, let us take it is NH4OH. If I add it with NaOH, one hint has been given, ammonia gas released. Fine. What else can we form? Na will go with something else. Tell me what it will go with. Na will go with something else. Achha. Both are oxidants, so it will not work. So let's change the reaction. Cl. Now what will happen? NaCl. Right? NaCl will take place. What else? Water. Clear? NH4Cl plus NaOH you add, you will get this product. This pungent smelling gas turns moisture litmus blue, NaCl and water. So when alkali, this is an alkali warmed with an ammonia solution, ammonia gas is given out. Clear? These are the chemical properties of bases that you need to remember from this part. Okay, done. Bases are complete. Bases over. Okay, now what to do? Now we'll move on to the part called pH, the most important part of acid base. pH. pH. P is small, H is capital. Okay, pH. P is small, H is capital. That is pH. pH is potence for hydrogen or power of hydrogen. Potence for hydrogen or power for hydrogen. Okay, before we start with pH, the thing you need to remember is the ionic product of water. Ionic product of water, that is denoted by Kw, that is ionic constant of water. Okay, ionic constant of water, the formula, not the formula, not there also. You have to remember the value, that is 1 into 10 to the power minus 14. It's look very odd if we write only 10 to the power minus 14. So we write 1 into 10 to the power minus 14. What is the unit? Mole square liter to the power minus 2. Okay, liter to the power minus. How are we going to write this? Clear? Same thing. Okay, so this mole square per liter square. Temperature is needed. Okay, you cannot write random temperature. So it's 25 degree Celsius. Okay, so it's 1 into 10 to the power minus 14 mole square liters per liter square at 25 degree Celsius. Okay, understood? This particular value is said to be the ionic product of water. Ionic product of water. Okay, this you need to remember. Numericals are there in equilibrium chapter of class 11. Okay. pH. As I have already told you, pH is potence for hydrogen. So a scientist named Sorensen, 1909, scientist called Sorensen, Okay, spelling now varies. Spelling now varies in different books. Somewhere it is written as like this also. Sorensen. Okay. Sorensen. So no one will ask you scientist name, so don't worry. So a scientist called Sorensen, he devised a scale called the pH scale to identify which one is acid, base and alkaline. Okay. So in that scale, the part 0.7 is said to be the neutral. Okay, and pH of water is 7, so it is neutral. Go this side, what will happen? 6, 5, 4, 3, 2, 1, more acidic it becomes. Okay, go this side, left side, more acidic. Right side, 8, 9, 10, 11, 12, blah, 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 more alkaline it becomes. Okay, I am using the term alkaline, right? And actually I mean to say basic. Okay, so more alkaline the term, more alkaline the substance becomes. So if the substance has got a pH of, let us take 6.5, it is slightly acidic. If something has got the pH of 8.2, slightly basic. If someone has got a pH of 2.1, very acidic. If it has got a pH of 13.2, very alkaline or very basic. Clear? So these are the type of questions that are often asked from here. Okay. Next is the pH formula, only to be known. No numericals are there. pH formula minus log 10 base hydrogen this. Clear? Hydrogen ion. This is basically the pH formula. No what problems or no numericals are there. Okay, just know the formula. Okay, pH done. Now let us learn about that how exactly pH is useful in our daily life. pH, how it is useful in our daily life. In agriculture, pH is required. Every plant will not grow in every condition. If the soil is too acidic, we need to add a basic substance. If it is too basic, we need to add acidic substance, right? In our stomach, enzymes, they will work at a particular pH. Excessive pH is not good, then acidity will happen. So in that case, you have to drink milk of pregnancy, right? Okay. Tooth decay. Tooth decay starts at certain pH. That is, pH falls to 5.5, then bacteria will grow. So there also there is a pH maintenance, right? Our body works from a pH range of 7 to 7.8, that is neutral to slightly basic, okay, but not acidic. Acid rain. Acid rain is also there. If pH of rainfall gets to less than 5.6, it is said to be acid rain. So these are all how pH is needed in our daily life. Another term we will get in pH is universal indicator. So it basically tells us about the spectrum of how it gives us a spectrum first of all, and it will tell us how much a substance is basic, alkaline or neutral. Okay, it's basically a mixture of all dyes. That is what is basically a universal indicator. What I mean universal, you can understand that. Okay, so that was all from the bases part. Now let us go to the salts part. Only 3 parts are there from salts. 3 types of salts. Okay, salts. So as you already know that salts are the chemical compounds formed by the complete or partial replacement of hydrogen atom by metallic ion or ammonium ion. That is basically salt. So based on that replacement, we have divided into neutral salt, double salt, mixed salt, complex salt, acid salt, basic salt. We are having in our syllabus only. We are only having first type neutral, second type basic, third type acidic. Clear? Nothing else we are having. 3 more are there, not there in your syllabus. Okay. So salt definition I have already said. Now let's move on straight to normal salts. Normal salts are formed by the complete replacement of the hydrogen atoms by a metallic ion or by a non-metallic ion. Example, I have already shown before also. NaOH plus HCl forms NaCl, okay, plus H2. So is there any OH radical? No. Is there any H plus radical? No. So they are neutral salts. Complete replacement. This Na has replaced this H. Okay. So complete replacement done. It is a neutral salt. Then next comes acid salt. Acid salt. Acid salts is formed by the partial replacement of the ionizable hydrogen atoms of a polybasic acid by a metal or ammonium ion. What does this mean? See, if I write NaOH and if I write here H2SO4, okay, suppose there is taking only one Na is there, so what will be the product form? NaHSO4 plus H2, right? So here there is H plus ion, yes, there is an H plus ion. Why? because 1 Na cannot replace 2, right? 1 will be left out, so 1 hydrogen is remaining in the product. This is acid salt. So it is partial replacement, right? Complete replacement not possible, so partial replacement of now ionizable hydrogen atoms. How many? 2 by the metallic ion, that is Na. Clear? Polybasic acid means basicity more than 1, as I have already told. This is a polybasic acid. Polybasic means dibasic, tribasic. 2 1, both are falling under polybasic. Clear? This is a polybasic acid. So it could not be replaced completely. So it is a partial replacement. This is what I was talking about. Okay. Done. Next comes the third type of salt, that is basic salt. Okay. Basic salt. Okay. Now if I write lead hydroxide and if I write HCl to it, if I add HCl to it, sorry, then what will be the product form? PbOHCl plus H2O. Why is it so? Check. How many OH are there? 2. How many H is there? 1. Well, can the H completely replace 2 OH? No. Then what will happen? 1 OH will remain. So 1 OH radical is here. This is the basic salt. Okay. What is the definition of the basic salt then? Basic salt are the type of salts formed by the partial replacement of the OH radical by the hydrogen atoms of a polyacidic base. Polybasic acid. Clear? It is basically the partial replacement of this hydroxyl group, that is basically OH minus ion, by a polybasic acid. Clear? By a polybasic acid, or you can specify by the hydrogen atoms of a polybasic acid. Okay. So here 2 was there, 1 is here. Could not replace, 1 is remaining. That is basic. Clear? In your book it is written as basic salts are formed by the partial replacement of the hydroxyl group of a di or triacidic base, that means a polyacidic base, by an acid radical. Okay. So this is more or less same thing. Clear? So this is all you need to read from the part of the salts, and with this part we come to the end of this chapter, acid, bases and salts. In the next video we will be discussing about the next chapter, is analytical chemistry, where we have to remember the observations mostly. Okay. So see you all in the next video. Keep watching the videos. Thank you.